Okay. So yeah, so they are telling you in this problem, this is 14 and chapter 11 section 2, right? So the integral from 0 to infinity of dx over y squared plus x squared is equal to pi over 2y, right? And they say differentiate both sides in order to evaluate, in order to figure out what to evaluate. So the question is, what's this? 0 to infinity dx over y squared plus x squared squared. Okay, so to go from one to the other. No. Well, now note that if you, in calculus, if you differentiate an integral, right, going, let's say from let's say from a to b, right, of some function, whatever that function is, and this function, let's say, has two variables, right? Let's say x and y, for example. And let's say that this function here is with respect to y, for instance. Okay, this is, as long as a and b are real numbers, what you could actually do, you could take the partial derivative inside, and this would become d of g as a function of xy over dx times dy. You could do that. Okay, so yeah, so I'm going to differentiate the above integral with respect to y using this. So if I do that, then I would say, so let's write it here. So d over dy, so I will apply this on the given function, from 0 to infinity of dx over y squared plus x squared. Of course, if I differentiate on the left with respect to y, I have to differentiate on the right with respect to y. So on the right, I have pi over 2y. So pi over 2 times y to the minus 1. I just brought the y up. Okay. And so now with this red theorem here, I could take the derivative inside the integral. So this becomes 0 to infinity d over dy, right? D over dy of 1 over y squared plus x squared dx. Already. And this is equal, so the derivative of this would be just, power rule minus pi over 2 y to the minus 2, right? And then, of course, here I would do the quotient rule on this. So this would be 0 minus derivative of the bottom, yeah. So 2y x squared is 0 times 1 over the bottom square. The bottom squared is just y squared plus x squared. Okay, squared. Dx. And of course, I have an integral here from 0 to infinity. And this is equal to minus pi over 2y squared. Okay, now as far as the integral goes, y is a constant because I can pull it out, because this integral is with respect to x. Okay, so I could pull minus 2y out, and then I have left from 0 to infinity 1 over y squared plus x squared dx equals minus pi, which is, by the way, this is what I'm trying to evaluate right here. So I can just divide both sides by negative 2y already. I can divide both sides by negative 2y. So divide here by negative 2y and here by negative 2y. So those guys go away. And I am left with exactly what I'm after. Integral from 0 to infinity of y squared plus x squared dx is equal to, so this becomes, the minus cancels the minus and you get 2y cubed. This is the final result. That's how you could figure out the answer of this of the last integral using the first integral. You see?
Oh yeah, I see. I think so. You basically you is like a substitution.
Yeah.
Okay.